Hello everyone, welcome to the 1911 Nobel Organic Chemistry Awards. These awards are the most prestigious awards for organic chemists worldwide. Therefore, any nominee for today has done outstanding work. So let's get right into the awards. The winner for the best newly discovered organic chemistry reaction goes to the Pictet-Spengler reaction, and our heartiest congratulations to the chemists Aimé Pictet and Theodore Spengler, who contributed to the reaction's discovery. Please come up to the stage to receive your prize.
Thank you so much for this prestigious award. We are so honored and proud of our work and so grateful for your support.
Wait, come back. After all your hard work, explain a little bit about the reaction.
Well, if you insist. After all, it was very fun. So we discovered this reaction in the year 1911. This reaction is an analog of the Matic reaction between a beta-arylamine and an aldehyde, followed by an electrophilic addition to arine to form a new heterocycle. It is the last of three basic mechanisms for producing isoquinolines and beta-carbolines from beta-arylamine. It is preceded by Biskler-Napriowski, which produces dihydro products, and Pictet-Gams, which produces the unhydrogenated product. The Pictet-Spengler reaction itself produces the tetrahydro product, and unlike the other two reactions, does not require a phosphate dehydrating agent. So this might seem like a lot at first, but don't you worry, we will go through all of the steps. But first, let's provide some context for this reaction. Beta-arylamines are very common in nature. For instance, they can be produced from essential amino acids, phenylalanine, tryptophan, tyrosine, and histidine by decarboxylation to produce corresponding amines. Isoquinolines and beta-carbolines have a wide variety of functions in biology, and many important drugs are isoquinoline derivatives, while many plant alkaloids with various and yet undiscovered functions are beta-carbolines. The corresponding reaction performed with the original amino acids produces a higher yield and easier reaction conditions. So how does the reaction occur? My partner, Spengler, who couldn't be here tonight, will explain now.
So how does the reaction occur? The amine attacks the carbonyl carbon of the aldehyde. Since this is the only member of the triad of reactions to use an aldehyde and not acid or ester, it obviates the need for strong phosphate dehydrating agents. The oxygen exits and an aminium ion is formed. Electrophilic addition occurs. A new bond is formed by pi electrons from the arine between the arine and the carbonyl carbon. Aminium reverts to amine and aromatically must be regained by loss of a hydrogen. In the case of indoles, a 5-membered ring will form at first and must rearrange to a 6-membered ring before regaining aromaticity. That's all, folks. It's super fun.
Thank you so much, Spengler. Here are some exclusive notes about the reaction that we thought you would all like to know, considering that this is the best reaction this year. The key step in the reaction is the electrophilic addition. Thus, the more activated the arine and the more electrophilic the carbonyl carbon, the more efficient the reaction. An acyl group makes the carbonyl much more electrophilic and leads to a higher yield. Indole ethylamine is more nucleophilic than phenylethylamine, so its reaction will be more efficient. Dopamine will proceed much more rapidly due to the activation and presence of a para-electron donating group. The reaction can be done with ketones as well to produce a disubstituted product, but typically requires a Lewis acid to produce the required electrophilicity. Substitution of the amine is possible, and such a beta-carbamine has been found in rat brains as the result of enzymatic activity. But this also tends to decrease the electrophilicity of the aminium ion and necessitate harsher treatment for the same yield. Electrophilicity of the aminium carbon is affected by oxidation state of nitrogen, which is why this reaction requires acidic conditions, or at the very least, an acidic catalyst to proceed. The more unfavorable the base reaction, the more acidic the environment must be for it to proceed. The reactants, as stated before, can be found widely in nature as amino acids, etc., but in the synthesis, the beta-arylamine can be generated by Friedel-Crafts acylation followed by a Clemmensen reduction. So there you have it, the Pictet-Spengler reaction. We'll see you all at the next awards.
This reaction was discovered in A. 1911, B. 2001, C. 1913, or D. 1897. You guessed it, the answer was A. 1911. Next, what makes this reaction unique? Is it A, that it needs a phosphate dehydrating agent, B, that it doesn't need one, C, it needs basic conditions, or D, it's made by beta carbolines? This one is a hard one, but the answer is B, it doesn't need a phosphate dehydrating agent. Alright, this last one's going to test you if you really paid attention to this reaction. So, what is the first step of the mechanism? Is it A, that a 5-membered ring rearranges, B, electrophilic addition, C, an oxygen leaves, or D, the amine attacks the aldehyde? While all of these are important steps in the reaction, the answer is D, the amine attacks the aldehyde, as this is the first step of the mechanism. Next, we'll show you a quick clip of the reaction from earlier in case you couldn't get this one right.